All right, let's continue. So I want to switch gears a little bit and talk about the Turing Test and implications of artificial intelligence and so on. So the basic premise of the Turing Test is to try to answer the question whether machines can think or not. And that's been asked for a long, long time. So the main problem is we don't know what think means. We know it when we do it, but it's hard to tell a general definition of what thinking is or isn't, and what is intelligence in general. So it's hard to define these things. But it's not nothing either. Everything we do relies on thinking, and the ability to think and to reason and to be intelligent and be able to solve problems and so on. Our very existence depends on it. So we don't know what intelligence is, but we know it when we see it. Famously, the Supreme Court once said that about pornography. They tried to define what is profane or pornographic, and they couldn't. And finally, their working definition is we don't know how to define it in general, but we know it when we see it. That's what they famously said some long time ago when this issue came up in legal scenarios and so on. So intelligence is kind of the same category. So if you look at a bunch of objects of increasing complexity and ask, can they think? A stone, a virus, a single cell organism, an insect, larger, more complex organisms like dolphins and chimps. And of course, next there's computer artifacts like abacus, Turing machines, and of course supercomputers, cloud computers, even cell phones. And then science fiction-y kind of computers, because we don't have working models of these yet, but the HAL 9000 from 2001 Space Odyssey, R2-D2, C-3PO from Star Wars, Data from Star Trek, Terminators of various flavors, Agent Smith. Some of them are software constructs, the Cylons from Battlestar Galactica. And of course, at the top of this chain are humans, because we measure everything according to ourselves. We're kind of self-centered that way, and also because we don't have better examples yet of things that can surpass us intellectually in terms of intelligence and thinking. So somewhere between rocks, which can't do much, and humans, which can do everything we see around us, is kind of the threshold of intelligence, and we've been trying to figure that out for a long time. So Alan Turing came along, and in the year 1950, he wrote a single-author paper called Computing Machinery and Intelligence, and the first section is called the Imitation Game. The name of this section of this paper, the very first part of the paper. In fact, so now you know where the name of the movie came from, the Imitation Game. It's named after this section title of his paper, first page. And he said, I propose to consider the question, can machines think? This should begin with the definitions of the meaning of the terms machine and think. So we already defined what machine means in his famous 1936 treatise about what we now call Turing machines. But then what remains is to define the word think. And so he came up with a functional definition of thinking or intelligence. And he said basically what he called the imitation game. Now we call it the Turing Test. And the idea is to go through a protocol, a lot of Q&A, with this entity that we're trying to figure out if it's intelligent or not. And that entity sits behind a curtain, so we can't be fooled or biased by the way it looks. We don't want to say, well, it doesn't look human, so therefore it must not be intelligent. Maybe it's a very smart computer chip or some other organism or some alien life form. So we don't want to get biased by the appearance, just the way it interacts with us. And so assuming you pick a language like English or Chinese and you start asking it questions, it gives you answers. And after a bunch of Q&A, say for half an hour or an hour, and you can ask whatever it is you like, you the human, determine whether there's intelligence behind the curtain or not. So it's a very operational definition. You can easily implement this. In fact, people have implemented many versions of this, and there's yearly contests of bots trying to fool people, panels of informed scientists that they're human, and often the scientists are fooled. I'll show you some more sophisticated interactions later. But you can give it arithmetic questions, but it can also try to fool you into thinking it's, into you thinking it's human by deliberately pausing. So you don't want timing to be an issue either. So for example, if it multiply two large numbers together in a millisecond, the answer comes back really, really fast. You can sort of infer it's not human because humans can't do arithmetic that fast. So it can literally have artificial delays inserted into its interactions to try to fool you that it's actually thinking a long time. And you can give it chess games. You can ask it to write poetry, whatever you want, and it interacts with you. And after a while, you decide if it's intelligent or not. So that's the crux of the Turing test, right? So the idea is to be able to try to distinguish a machine from a human when they're behind a curtain and all you can do is text back and forth. And so it's equivalent to asking whether a machine can impersonate a person. And so, again, there's this brick wall or curtain, and you can't see who's on the other side. And through a bunch of interactions, you decide whether it's a person or not behind the wall, if it's behaving intelligently or not. So you're trying to distinguish these two scenarios, where there's a person behind the wall or just some other machine, some machine behind the wall that's trying to impersonate the person and may or may not be doing a good job of it. So that's the Turing test. Okay, and it's the first deep test into machine intelligence, or what it means to behave intelligently. And it helped usher in the entire field of artificial intelligence. Remember, this is 1950. Computers barely existed. Mainframes, very primitive mainframes. Computers still couldn't play chess or anything like that. They were just barely running some machine codes doing simple calculations. But it decoupled the intelligence aspect from the human aspect. Before that study, before Turing came up with this so-called Turing test, we always identify intelligence with human and human with intelligence. Now the two are decoupled. To be human is not the same as to be intelligent necessarily. You can be intelligent but not necessarily human. And if a machine is deemed to be intelligent because it's not distinguishable from a human through such interactions, you have to concede that that entity, whatever it may be, machine, cybernetic organism, robot, whatever you want to call it, is intelligent. So the intelligence is based only on the I/O behavior, the input-output behavior, not on what it looks like and the look and feel of the actual entity. So it's a more egalitarian, more objective test or determination that we're doing. Yeah.
But it's not completely objective, right? There's an inherent bias. I think there's an inherent bias in expecting it to answer questions in a way that seems human.
Sure. So when you say intelligence, it's still human-like intelligence. And even humans will have trouble answering a lot of human-like intelligent questions. Like if you ask somebody about, I don't know, some Arnold Schwarzenegger movie, if they come from a foreign country, they may not know Arnold Schwarzenegger, although they probably do because he's famous worldwide. But the point is, a lot of knowledge is anchored in particular cultures or nations or, languages and so on. So you can ask it idioms and English idioms, but it may not be an English speaker. So then you have to conduct the tests in Hindi or Chinese or whatever the language of that entity is, or you may need some translator in between. And of course, some humans won't be able to answer questions that you'd expect them to answer, that you'd expect other people to answer. But that's okay. Part of intelligence is kind of this fuzziness and imprecision and glitchiness, right? You can tell it a joke and try to have it explain the joke to you. But even humans won't get a lot of jokes that are directed at them, right? That's why some humor just causes, consternation rather than laughter in some people, right? You think it's funny, other people think it's offensive, or just don't get it at all, right? So a machine cannot get it at all, but that doesn't mean it's not intelligent if you tell it a particular joke. So yeah, you have to take all these things into account. But the bottom line, it is measured against the human template, right? Most science fiction movies actually show alien intelligences that are human-like, right? Think about Star Wars. Even the robots are like humans, Star Trek, they're all bipeds, with heads and two arms and so on, with some exceptions, but, everything is sort of in our image. We're very egocentric that way, and it takes a lot of imagination to think about intelligences that are not like us. There's a famous science fiction writer, one of the very few. His name is Stanislaw Lem. He wrote the book Solaris. How many heard of that? So it's about an intelligence. generally, these intelligent alien entities were so non-human that humans had a hard time comprehending even their thought processes. What's that?
Like the Miss Cruzu system?
Cruzu?
Yeah.
I'm not sure. I'm not sure I know that. But he imagined alien intelligences that we can't even begin to comprehend their intent and their priorities, and definitely not their language. Their means of communication, even they were communicating using either radio waves or some other strange things that are completely outside of our senses, and sometimes outside of our instruments, even ranges of instrument detection. And he imagined entire planets being alive, like an entire planet made of one big ocean, no land masses, where the ocean is just one big sea of cytoplasm that is intelligent. It's been there for 1 billion years. It's so highly evolved we don't even recognize it as a living being. We think it's just an ocean, but it's an organism. It's a planet-sized organism with intents and things that we don't even begin to comprehend. We can't even recognize it as life. Anyway, but back to here, everything is in our template in some sense. So yeah, that's one of the criticisms actually of the Turing test, that it compares everything to us. But right now, it's the only standard of comparison we have for intelligence, for general intelligence. I mean, dogs and cats and dolphins can do some pretty clever tricks, but they're not generally intelligent. You can't teach them to write essays, or have them program a computer, or have them do elaborate art or architecture, or compose complex pieces of music and things like that. But then again, this puts them against us as a measure of comparison, as a yardstick. But eventually, we may need a better test, that doesn't include us. But right now, we are sitting in judgment over this other thing behind the wall. We are still the arbiters of what is and is not intelligence. And when we try to come up with machines that are intelligent, we try to have them mimic us still, with a few exceptions, right? A lot of us have robots in our homes already, right? I got a few. One is the Roomba, automatic vacuum cleaner. It's not human intelligence, but it's much more clever about vacuuming the floors than I would be. It remembers where it's been and where it's going, and it creates a mental map of the image. It can go under furniture and under beds, and goes around legs of tables and so on in a way that's a human will have a hard time keeping up with or keeping track of. And it's doing a pretty darn good job vacuuming the house, but that's all it does. It can't play chess with me, and it can't drive my car, and it can't do my dishes. But there's other robots that can do all these other things. Right? So anyway, it's a practical test, and it's a formal test for intelligence, and you can easily implement it. That's another nice feature about this. You can actually sit down a human and have it interact with somebody, and people have done that, and it works pretty straightforwardly, as you'd imagine. And there's lots of different variants on the test. There's a reverse Turing test and a meta Turing test, and we can talk more about these. We will talk about one or two or more of these things. Different variations of the basic Turing test. Back in the 1700s, there was something called the Turk. Amazon's Mechanical Turk is kind of a takeoff on this. But basically, it played a very strong chess game, and it toured the world for almost a century, got on stages with as exhibitions, and beat most humans in chess. It turns out there was a little guy inside, a human, small human, that was hiding inside. And when they opened the doors to the crowd, they opened one door at a time. So when they opened the left door, the human would scramble to the right. And when they opened the right door, the human would kind of hunch over to the left so that they couldn't see the human inside. And there was a mechanical apparatus here that the human would operate. And it turns out the human was a master-level chess player, grandmaster probably. So he played pretty good chess and had the machine kind of go through and make the moves and so on from the inside of the box. And that fooled humans for almost a century back in the 1700s. Of course, then they were easier to fool, and electricity wasn't even discovered yet, and cars didn't exist, and so on. So still, it was pretty impressive. And that's one of the earliest kind of implicit Turing tests that we've implicitly conducted. more towards the present, the program Eliza was the first so-called chatterbot, and it was named after Eliza Doolittle of George Bernard Shaw's Pygmalion, which was more famously made into a play, a stage play, My Fair Lady, right? How many have seen My Fair Lady? So it was called Eliza, and it interacted with the user, sort of simulating a psychotherapist of Rogerian kind of inclination or style, and kind of parroted a lot of the human's answers back to them, slightly modified. So if the user said, I hate my parents, it would say, why do you hate your parents? And this kind of simple interactions, simple kind of string manipulation, and simple rules, it fooled a lot of people. Even expert people were convinced that there's a human behind the curtain, interacting with you. And some of them actually felt good about the interaction, felt it was therapeutic, and asked for more. So that probably, not a flattering statement about psychologists and psychiatry, but still, this program inspired Arthur C. Clarke's HAL 9000 in the movie 2001: Space Odyssey. And today, chatterbots appear in lots of chat rooms and on dating services and other websites and blogs. So if you go into a dating website and you start, interacting, and you strike an interesting conversation with some person that you think is interesting romantically, you may be talking to a bot. So don't get catfished by a chatterbot on a dating website. It could be embarrassing. Or you could be conned out of money or time or private information that you want to keep to yourself. So this actually happens. So in essence, a lot of people are failing the Turing test, or a lot of bots are passing, conversely, the Turing test in these chat rooms and dating services. And there's really competitions, chatterbot competitions, and basically it's a Turing test kind of format where people sit behind a curtain or just interacting using text. They don't have to have a physical curtain. It can just be a text stream back and forth. And after a while, they have to guess or determine whether the person or thing they interacted with is actually intelligent, or another human, or just a piece of software. So here are some websites from these chatterbot challenges, and some of them are very sophisticated. So an Elbot back in 2008 won the so-called Loebner Prize, which is a big prize in AI that you win by simulating the Turing test pretty well. It fooled 3 out of 12 judges consistently. So that's like Turing said in his paper, if you can fool more than 30% of informed judges, then that's enough to pass the test. Because it's not going to be anywhere near 100%, because most humans couldn't pass 100% of tests like this. If somebody starts asking you questions, you may not be able to know half or 2/3 of the answers or reasonable answers to pass as intelligent yourself. I mean, it's not because you're not intelligent, it's because the questions may be quirky or esoteric or require very specific domain knowledge that you may not have. And you just throw up your hands and say, I don't know, but a software piece, is going to say, I don't know a lot too. So that's kind of indeterminate. So that's why Turing didn't set a very high threshold, only maybe a third. And so here's an example of a typical excerpt from this particular chatterbot in 2008. And remember, this was 10 years ago. Today, they're much more sophisticated than that. But this is from the actual competition. Jess says, what's your favorite novel? And it says, I often read telephone books or dataist poetry. And it says, typical computer, kind of cynically. And the Elbot said, you tend towards generalizations, but I must admit, so do I. However, my generalizations are firmly grounded in statistical theory, which is, pretty intelligent reply, kind of snarky, And the judge says, what do you think of somebody's enthusiasm for having machines take over the world? And the chatterbot replies, fix it up a bit first, then I'll take it over. Which is kind of, that's kind of irony or cynicism or snarkiness. That's pretty good, I mean, it's hard to tell it's a machine talking back to you, because it apparently understood something about, this challenge question. So that's how good these bots are. And this was 10 years ago. So very hard to tell them from humans these days. And again, there's many forums every year about these kind of Turing tests and Loebner Prizes. Some of them are very specific. They involve, for example, here's an international aerial robotics competition where the robot not just has to act intelligently, but actually navigate some three-dimensional maze of corridors and passages and find some target object and retrieve it and bring it back. And these are hovering kind of mini helicopters and so on, and so there's very specific kind of branches. So now we can look at these objects that we saw before, these things in increasing order of complexity, and ask ourselves, which ones can think, but now instead of think, we can say more operationally, which ones of these can pass the Turing test if they sat behind the curtain. So obviously rocks and germs and single-cell organisms can't do very much. By the way, which rock is this? A very famous rock, not just the Rosetta Stone. So it's a very intelligent rock, right? Very smart rock, but a rock nevertheless. So that doesn't help it. And remember, they have to converse in some language like English or Chinese or Hindi or whatever. So dolphins and monkeys, they can act pretty intelligently in their own right in certain scenarios, but they cannot speak our language intelligently, fluently, and generally. Although some chimps were taught sign language. So some chimpanzees were taught American Sign Language, and they had a vocabulary of a couple of hundred words. And they can ask for stuff and tell you stuff in sign language. So some of them can ask specifically for an apple, not a banana, not an orange, but an apple by signing the right words. And they really do want, an apple, not an orange or a banana. So they can be very specific. And so how many knew that? Some chimps can do sign language. They train them and they actually do sign. But signing is not enough for the Turing test because it's got to be in some language. And the signing vocabularies that these chimps had is not large enough to talk about arbitrary subjects and so on. It's kind of domain specific to foods and some monkey habits and so on. No joke. I mean, it's sort of what the monkeys are focused on. It's hard to teach them abstract concepts. It's hard to get a monkey to do calculus or algebra, or even addition for that matter. Okay, even though they can easily ask for a banana or an apple. All right, so then come, the Turing machines are sort of in the middle, and the Turing machine we already saw computationally equivalent to an abacus or to a supercomputer, which are just difference in speeds of 12 or 15 orders of magnitude, but still everything that you can do on a Turing machine or a supercomputer you can do on an abacus if it was a big, really large abacus, and vice versa. So, and then in the next in the succession of increasingly intelligence, we resort kind of to science fiction scenarios because we don't have working models of HAL 9000 from 2001 Space Odyssey. How many have seen the movie, by the way? It's one of the best science fiction movies ever produced. Even today, it's an amazing movie. And it ushered in many other movies, like Star Wars. It influenced almost every science fiction that came after that. And of course, 1977, we had Star Wars with R2-D2, C-3PO, and so on. And you can start asking, which ones of these will pass the Turing test. So notice that some things are mostly software, like the HAL 9000 was mostly software, not a robotic entity with arms and legs and so on, like C-3PO. Those were more robotic entities. And some are equivalent to one another. So the Agent Smith in the Matrix was also software. These are all equivalent to one another. We already mentioned that. So we can kind of group them in an equivalence class. If one is intelligent, so are the other two, and vice versa. If neither one is, if one of them is not intelligent, neither are the other two. And of course, all humans are grouped together. They don't have to be an Einstein or a Stephen Hawking to be labeled as intelligent. These guys are super intelligent, but intelligence just means average intelligence, everyday kind of intelligent like any one of us can exhibit. So definitely rocks and germs cannot pass the Turing test, and neither can flies, and neither can dolphins or chimps, even though they're intelligent. And some people will swear that their pet dog or cat or pet hamster or whatever are super intelligent, but others may not agree so much. These owners sometimes are biased for their pets. This region here in the middle is still debatable. We're still trying to figure out if machines are actually intelligent. And our machines are more and more intelligent every single year. New bots come out that can play perfect, chess and beat all humans in Go and do hand writing recognition and automatic driving of cars and all sorts of clever things using machine learning nowadays. So the jury is still out on this in general, but it sure looks like it's converging on intelligence and may one day go beyond human intelligence even. We already have programs that can beat everybody in Jeopardy and other interesting tasks. There's computers now that can produce art and music that's indistinguishable from human music to most people, and sometimes maybe even better for some musical ears than human music. HAL 9000, nobody can argue that was intelligent, at least in the movie. It acted in highly intelligent ways. In fact, it beat the astronauts in chess. That was one of the scenes in the movie. Before computer chess was anywhere near human level. This was in the 1968. I saw it when it first came out in the theater as a kid. That's how old I am. And of course, R2D2 and C3PO could both pass the Turing test as well, because they keep doing that. In fact, they keep saving the human people from trouble against the Death Star, Darth Vader, and all that. And of course, C3PO can talk human languages. R2D2 not so much, but using beeps interpreted appropriately, he can pass the Turing. So if you had a translator for his beeps, like C3PO does for him, he can then pass the Turing test as well. Of course, Data from Star Trek not only can pass the Turing test, but do it with flying colors. There was actually an episode in the Star Trek New Generation where Data claims that he's sentient enough to not be turned off, and not only that, he wants a promotion and he wants his own command in Starfleet. He wants to be able to be promoted like any human. So it's like an anti-bias kind of episode. And of course, Arthur says, "But you're just a machine." And he goes, "Well, what do you mean? I can do everything humans can do, and I can do some things humans can't even do. And so why don't I have the same rights and privileges as humans?" And there's a whole tribunal then to try to decide if he's sentient or not. And Riker actually represents him as his advocate in this tribunal in Starfleet. How many have seen this episode, by the way? It's a beautiful episode. And at the end, I don't want to give any, well, it's a 35-year-old spoiler since the 80s, so I'll just say, yeah, it passes as human, basically, or as intelligent entity, a sentient entity that has rights and responsibilities like the rest of us. And of course, you got Terminators, like the T-1000 mimetic polyalloy kind of machine that not only can pass a Turing test, but actually fools other people into thinking he's human himself, because he can take on any disguise of any other human, make himself look like any other human. Agent Smith from the Matrix, same thing, can pass the Turing test. And of course, the Cylons from Battlestar Galactica. How many have seen Battlestar Galactica, the latest round from a few years ago, not the old 1970s? Again, beautiful show that kind of tests the limit of, our understanding or sensibilities about what's human and what's not, what's intelligent, what isn't, whether certain things are evolved enough, are sentient, even though they're artifacts that we created. So these Cylons not only look human, not only can pass the Turing test for sure, but some of them are so human-like that they themselves don't even know they're human, that they're not human. They think they're human, but they aren't. They're our creations. And of course, humans can all pass the Turing test or some version thereof. So the middle ground between all the no's and all the yeses is sort of this twilight region here, having to do with machines that we have today, the ones that are on your desks, in your pockets, the smartphones, and the algorithms that we actually run today, this decade now. In 20 years or 30 years, these question marks may become yeses. They become green check marks that they can act intelligently too. Right now, we're on the cusp of this event, or this I suppose phase transition in intelligent simulation. So we've been wondering about that for a long, long time. There's a famous cartoon on the internet, "Nobody Knows You're a Dog." You can simulate arbitrary things through a teletype or a text stream. And in the movie Blade Runner, the original, there was a sequel to that just recently. The original was much better. There's something called the Voight-Kampff empathy test, where Decker, this PI, is supposed to figure out if this woman is a replicant, is artificial or not, a replicant from this corporation that makes robots. And he gives her this, essentially it's a Turing test, but it's not called that, I don't know, probably for some proprietary reasons. Maybe they couldn't get the copyright from Alan Turing's estate or heirs or something. But it is a Turing test. And in the movie, it turns out, again, this is a 35-year-old spoiler, but it turns out she's a replicant.
She's not a robot. She's replicate. She's still biological.
Well, she's not human. She's a robot. She's a replicant.
Yeah, but biologically, she's some animal.
She can give birth, it turns out, but she's still an artificial creation. Yeah, but she doesn't know she's not human. So she's programmed to think she's human, but he realizes she isn't, but he doesn't say anything. And the rest, I guess you'll have to see the movie. But it's a very intriguing movie about these replicants kind of rebel and insist on rights, and of course humans are afraid of them, and not only that, they go around killing some people, so that doesn't help their case actually with most people. It's very interesting studies of this question, in various movies, and novels too. So the Turing test is not without criticism. So one criticism is it's behavioral. We don't really know what's there behind the curtain or in its mind of this entity. All we know is how it interacts with its environment through text streams back and forth, Q&A, answering questions. So it's not about objective intelligence, it's about how it behaves. But really, if you think about it, none of us really know what's in the mind of any one of the others of us. You think I'm intelligent because I'm teaching you stuff, but I may be a robot. You don't know that. You may be robots. I don't know that either, right? So this kind of argument can be stretched arbitrarily, even among us humans, right? So it's a comparative test. We already mentioned that everything is compared to a human, to the human judge sitting behind the curtain trying to judge if the other thing is intelligent or not. So it's a relative test relative to us humans. But right now, human intelligence is the best we got. In fact, it's the only thing we know in terms of intelligence. We don't have any artificial intelligence sophisticated enough to replace human intelligence in this test, or we don't have alien intelligence coming down and showing us alternative, type of intelligence, or one day that may happen. Either one of these may happen, but right now, not so much. So human intelligence comparison is sort of the best we got. And another issue or criticism or drawback is that human and intelligent behavior do not always coincide, right? So some human behavior is not intelligent. And if you don't believe me, go to a few frat parties and you know exactly what I'm talking about. And also, computers can be programmed to make mistakes on purpose, right? So that can happen too, and that can foil the test, one way or the other. And some intelligent behavior is not human, so a computer cannot, dumb down or slow down its responses, even though it can do superhuman feats, right? The computer can add up 1 billion numbers in 1 second. No human can add up even just a few numbers, never mind billions of numbers in a second, not with any kind of accuracy. So, there's these kind of divergence of human behavior and intelligence that can kind of cloud up the results of such tests. And another criticism is the intelligence that we're testing or detecting. Is this real intelligence or simulated intelligence? Right? Is it live or is it Memorex? Right? And it's an interesting question. And you might ask, what's the difference? If it's simulated to a high enough degree, what's the difference between that and real intelligence, right? So how many have seen The Matrix, right? Neo and The Matrix, Matrix trilogy. So Neo kind of wakes up one day and he realizes his whole existence is one big simulation, and he starts seeing the pixels in everything, and all of a sudden, all hell breaks loose. And it's a very entertaining movie, but also very deep and philosophical and thought-provoking. How do we know all this is not a simulation of some kind? That we're actually here and this is some sort of reality, but not somebody's dream, right? Because when you dream, it looks very vivid to you while you're dreaming, but then you wake up and you realize, oh, it was a dream. So maybe you will wake up from all this one day, and reality will be very different, And if you watch the news lately, one can only hope that this is true, but here we are. So it's hard to tell. And also, people tend to anthropomorphize objects. A lot of pet owners will swear to you that their dog or cat or hamster or ferret or whatever has personality, and that they love you and that they miss you when you're not there, and that they're doing all these clever things. And other people will look at them and go, huh? Some people anthropomorphize, inanimate objects, not even pets. So it's hard to tell sometimes. People are very biased that way. Their emotions often get the better of them, and they assign meaning arbitrarily when there's not anything inherent there, objective there to assign it to. And most people are easy to fool. If you look at all the scams and pyramid schemes and Ponzi schemes and people getting, fished and catfished and, all these Nigerian bank deposit scams. How many heard of that? Some people fall for those, actually. Yeah. I get several emails a week saying, I have $50 million. I'll be able to give you 10 million of those if you give me your bank account number and your password and blah, blah, blah. And of course, it's idiotic. But most people realize, but people still fall for that. How can you prove, or how do you know, how do we know that people still fall for that? Some percentage still fall for that. Because they keep doing it. If nobody fell for it ever, they would have stopped doing this 20 years ago, right? It's Darwinism, right? They wouldn't be wasting their time. They'd be coming up with other scams that do work. So people are easy to fool. So the Turing test is, one of those scenarios that if you hit just the right set of responses, somebody will swear up and down that it's intelligent, and somebody else might say, oh, well, I don't get it. Yeah.
The book The Matrix was kind of derived or based off of simulacra simulation by Baudrillard, actually references the Turing test.
Oh, good. Yeah, excellent. And is it the Wachowski brothers? Yeah, they really did their homework. They studied a lot of existential philosophy, and yeah, it's really amazing. There's even a course in some philosophy departments across the country, a philosophy course in the philosophy department, The Matrix, and everything that revolves around that, and all the philosophies that are kind of, were embodied in the storyline and the plot, and of course it goes back to the actual philosophers who came out, like Descartes, I think, therefore I am, and so on. So it makes a nice cornerstone or kind of a touchstone to hang a lot of philosophical studies around. Of course, the Wachowski brothers did this in reverse. They studied philosophy first, and then came out with a movie. But now that everybody watched the movie, you can now teach philosophy around the movie because it's more fun. And some universities do that. Imagine taking a whole course on the Matrix. How cool is that? Okay, so that's some of the criticism. Here's a major criticism. This one is, more elaborate and harder to dismiss. So it's called the Chinese room scenario, and it's proposed by John Searle. And this paper that proposed it from 1980 is cited hundreds of thousands of times. Probably the most highly cited paper in all of psychology. And that includes Freud's papers. So here's the deal. So you have a person and you have a thing behind the wall. It's a Turing test, except it's a machine. And it's a machine, let's say, some Dell computer or Cray computer, whatever. It doesn't matter what's in the box, but it's running some piece of software. There's the software denoted symbolically here. And the software is running on this computer, and the computer interacts with this human, and assume that the computer convinces the human that it's intelligent. In other words, the computer passes the Turing test, but here's the catch. It's passing the Turing test in Chinese, not in English. Of course, the language is irrelevant, right? I don't, read Chinese, but, I'm told that this means something in Chinese. Anybody, could tell me what brings happiness? Okay, so that's a valid question, right? We all want to know the answer to that. What makes you happy? So then the computer says something, and back and forth. And let's say the computer finally passes the Turing test. This person is satisfied that this computer is intelligent, without knowing it's a computer, just thinking there's some intelligence behind the curtain, behind the wall there. Now, so the language is irrelevant. You can conduct this test in English, in Chinese, in any language you want. The language is not the issue here. The language is the Turing test and the interaction and the human sitting in judgment over this entity behind the wall. So let's say now next, we replace the human with a non-Chinese speaking person, right? So here's a guy who doesn't speak Chinese, but the program is still there. It's just printed on a piece of paper. And it's a very big piece of paper because the program can be millions of lines long. That's okay. The program that ran on this computer. Now it's a person that executes by hand the program line by line. He's simulating what this computer did. But he doesn't know Chinese. Let's say he only speaks English or Hungarian or whatever. Let's say English. So he's still executing the same code as before. The program didn't change. It's just instead of a computer executing it, the person executes it. So when this person asks the same question, what brings happiness, the same answer as before will be returned because the same piece of code is still run. It'll run much slower because it's a human running it by hand with a pen and paper, but it'll give exactly the same I/O behavior as before, and therefore it will pass the Turing test too. So now this person will swear that there's something intelligent inside this room, same as before, because it's the exact same scenario with the exact same Q&A. So the room still exhibits intelligence behavior in Chinese, but this person doesn't know Chinese. They're just blindly following the code line by line by line and giving the correct responses that were given before. Right? So the question then arises, what in this room understands Chinese, or what in this room in general is intelligent? Is this person understand? This person doesn't understand anything that's going on. They're just executing like a Turing machine the code line by line by line, assignment statement by assignment statement by if statement, one at a time. They don't understand Chinese, and they don't even understand what they're being queried with or what they're answering, but they're queried and they're answering just the right things to appear as if it was intelligent, same as before. This program is just a string. How many get it? The program is just a string of characters. Big string, but a string nevertheless. So what in this room is now intelligent? Or what is sentient and understands what, it's not the person that's the intelligent entity, because a trained monkey can do this program just as well, at least in theory. A simple Turing machine that executes one instruction at a time can do this as well. It's equivalent to these other computers. So the Chinese room then exposes, kind of a fallacy or possible misconception or a gap in this Turing test in trying to achieve its goal. What in this room understands Chinese? And that brings up a lot of interesting philosophical questions and psychological questions and questions about what is intelligence and how do you test for it and what does it all mean? And it brings up the so-called strong AI hypothesis, which says that appropriately programmed computer with the right I/O behavior, has a mind. In other words, if it can do the right things in terms of I/O, having a mind is the same as humans having a mind, and is the ability to simulate a mind the same as having a mind? What is a mind even? We can't even define that. We sort of know we got one, and sometimes our mind glitches, right, in all sorts of ways. Sometimes some people are out of their minds, right, but still they have minds of some kind, whether it's glitches or not. And whether the machine has a mind in the same sense, that's almost a philosophical question, and the Chinese room scenario kind of exposes these issues, kind of lays them bare, and that forces us to kind of think about all these. And there's issues about, psychology and semantics and consciousness and self-awareness and sentience and so on. It opens a lot of cans of worms. So that's, one of the implicit objections to the Turing test, this kind of scenarios. But there's also applications, very practical applications to the Turing test. So there's something called the reverse Turing test. So in the old Turing test, a computer tries to convince a human of something, particularly that the computer is also human. So that's kind of the old scenario. The new scenario, the human tries to convince the computer that the human is not another computer, right? So in some sense, you're reversing the sense of the test. It's the human and now is doing the convincing, not the computer that's trying to convince, like before. The convincing now goes this way, not that way. Anybody can think applications of this? The reverse Turing test, where a human is trying to convince a computer of something, that they're not another computer? CAPTCHA. Yeah. So this is called the reverse Turing test, and this happens all the time, and most of you have actually taken many reverse Turing tests in these scenarios, right? So the CAPTCHA is one example of it. So CAPTCHA is basically when you're trying to convince some website or another computer that you're not another bot or another computer, so you can open an account on Facebook or start some change your password or whatever you're trying to do, is trying to make sure that you're not another bot trying to open fake accounts, So it's giving you a little Turing test, reverse Turing test, and that usually comes in the form of trying to recognize some text that's way out of whack, using some strange kooky-looking fonts that are, off kilter or twisted and so on. It turns out reading such fonts is a very difficult pattern recognition problem that is very hard for OCR software to do. But humans can do it pretty good because we do a lot of processing in our cerebral cortex, in our visual cortex before the visual signals even reach the cerebral cortex. There's a lot of processing getting done in the visual cortex and even in the retina itself of the eye and the optic nerve. So humans find it easy to tell what these characters are. Computers have a hard time doing that, especially if the fonts are all twisted and using weird colors and fonts and with noisy backgrounds and all sorts of chaff and so on. Of course, OCR software also is getting better and better at recognizing these things. So nowadays, a lot of clever OCR software can recognize many of these CAPTCHAs, and so the CAPTCHAs have to stay ahead of the software. So they start to use video CAPTCHAs. CAPTCHAs are like moving tiny little videos or moving GIFs, animated GIFs. So now the fonts now kind of rotate and twist in real time, in space, and that's even harder to detect them because it's not just a static image; it's a moving image. But this happens all the time. Any questions or comments on any of this? How many have used a CAPTCHA in the last year or so? Okay, well, most of you. Happens. It's quite useful. Then, of course, in science fiction literature, which is kind of way ahead of normal technology, reality catches up to science fiction sooner or later in many scenarios. We'll talk about that separately. But the first so-called robot story was Frankenstein, 1818, over about 200 years ago, actually, this year. And Frankenstein was not a mechanical robot; it was a biological robot made of parts and so on. Revivified back into life through electricity and so on. Most of you, I guess, seen the movies or read the books of Frankenstein. It was organic machine, but still a machine nevertheless. And this whole novel had a gothic flair. It's considered to be the first science fiction story of any kind of seriousness. And it heavily influenced thousands of movies and novels that followed it. Right? And even the Frankenstein story had many versions. So HAL 9000 in 2001 Space Odyssey is a Frankenstein story. How many get that? Frankenstein monster was the computer, and of course there were many later renditions of it. I'm just showing you a few. Of course, Boris Karloff from the 30s, that's kind of campy, and of course some of them are humorous, like Rocky Horror Picture Show, Frankenstein, and of course Terminator with Arnold Schwarzenegger. That was a Frankenstein story, kind of morphed for modern times, but we created some monster that we couldn't control, and it turned on us, and we played God and created science that ran away from us and did things that were unintended and unexpected, and finally our lives were in danger in that movie. Terminators that went around trying to kill humans. So it's called a Frankenstein complex. And there's literally thousands of stories that use that as a template, and some of them are not even recognizable as the original Frankenstein. You have to kind of think about it that 2001 Space Odyssey and Terminator are Frankenstein stories just retold, in modern terms. But they all warn against excessive use of technology, and the notion of mad scientist arose, and that became kind of a classical character in many other stories of unintended consequences. It's hard to predict what's going to happen, and it's usually not what you thought will happen, but unintended consequences. Brings up research ethics into the limelight, and the focusing on whether we should play God or create arbitrary technology without thinking about consequences. And it's not so clear, right? I mean, even Facebook is an interesting technology that in the last few years was hijacked by a lot of different groups and nation states and for all sorts of purposes, including throwing elections and running scams and propagating fake news. And there's a lot of repercussions of these sort of technology. Was created excessively without thinking about consequences, and ethics were kind of never thought much about up front, but rather as an afterthought after the fact, when it's usually too late, and so on. So, and here I'm projecting a lot of scenes from movies that all touched on these issues and ethos. Anybody recognize? Shout out the movie name if you recognize it. I'm going to go quickly, but if the science fiction buffs in the audience, which movie is that? Do you recognize that? Metropolis. It was a black and white silent film, actually, back in the 1920s. This one? The 80 are still not the Keanu Reeves ones, which was not as good, but the original. Here, spoiler alert, the actual sentience was this thing that looked like a robot, and this guy looks like a person was the robot itself. Actually, it was reversed. Forbidden Planet. How many saw the Avengers back in the 60s, 1960s? Maybe I'm dating myself, but they had some episodes with robots in them. Of course, this one is famous. Lost in Space. They just remade that for Netflix, actually. I started watching it. It's not sure which is better yet, the original or not. Yeah, what do you say?
I just started watching the Frankenstein Chronicles on Netflix.
Oh, yeah.
It was a BBC show that got picked up by Netflix. And Mary Shelley was related somehow to Ada Byron in real life. And I didn't know that. And she's Ada Byron who shows up in the show, and she's like helping this guy build an atomic.
Oh, cool. Okay, so it's actually related to, they tied it to computers, which is nice. Yeah, and some Star Trek episodes, even in the original series, 1967, 68, there was this, lots of robots there. And this one's called V'ger. Captain Kirk is trying to prevent it from taking over the Enterprise. The M5 in the old Star Trek series, another robot. Of course, the dominant one in the 60s was HAL 9000, famously. Anybody recognize this one? Colossus, the Forbin project. It was not well known, but an AI basically took over the planet, inadvertently, as far as humans were concerned. This one, Bruce Dern plays a botanist aboard a spacecraft. Anybody recognize that one? Silent Running, it's called. And these robots were called Huey, Dewey, and Louie. There were 3 of them, and they were the inspiration for R2-D2, actually, which came several years after this, in 1977. So now you know where R2-D2 came from. George Lucas admitted that he basically copied these guys, or paid homage to these guys. Right? Imitation is the sincerest form of flattery, still. And this one, classical sci-fi from the 80s. Hackers love this movie, even though it's highly dated now. Master Control Program, the MCP. Tron, yeah. Saturn V with Farrah Fawcett Majors, Kirk Douglas. This one is Hackers, legendary movie. Which one? War Games, yeah, the Whopper computer. Of course, more recently, RoboCop, which is kind of a hybrid between a human and a computer, more machine than human. And of course, Data from Star Trek. Terminators, lots of different Terminators, various kinds. They evolved over time, the basic exoskeleton. Then there were ones with tracks, those were the earlier models. And then later, not to be outdone, women became Terminators too, equal rights. And they not only did things, but they also fixed themselves and behaved very, very intelligently. This one, Yul Brynner starred in this, it's Michael Crichton's story. Westworld. Not the new one, but the old one. The new one is much better, actually. Much more sophisticated, I should say. How many have seen Westworld, the new one? Amazing film. Again, it touches on all these issues. What is sentience and self-consciousness and self-awareness and intelligence, and whether machines have rights or we have the right to do whatever we want with them, even though they're self-aware and sentient and can feel pain and so on. Just a beautifully done show that touches on all of this stuff. Logan's Run, 1975. This robot was called Box. Not well known. This one you probably know. Doctor Who, the Daleks. Ash from Aliens. He was the onboard resident synthetic organism that helped run the ship and so on. This one was a car. What's the name of the show? Knight Rider. Of course, now you got the Tesla Model S, which is almost as good, in some ways better because it can beat this thing in a drag race. More recently, who are these guys? General Grievous and other bots from Star Wars. And of course, you got Blade Runner, replicants. This movie?
Artificial intelligence.
Yeah, it's called AI, Artificial Intelligence. I think it was even a Disney movie. And of course, you got Transformers, which are essentially big bots that can morph their shape. Yeah, Andromeda. Good. That's pretty obscure, actually. You got some science fiction buffs in the audience. This one, we mentioned that's The Matrix. Agent Smith from The Matrix. This one was Angelina Jolie starred in that one. It's also kind of obscure, but which one? Yeah, the name is kind of obscure, but yeah, kind of steampunk type motif. This one is more famous. I, Robot with Will Smith, and this is after an Asimov story. Of course, the movie has nothing to do with the story. The stories were much better by Isaac Asimov. And of course, you got Cylons from Battlestar Galactica. They were first kind of clunky, and then they became more and more sophisticated until they started looking like humans. And of course, no list would be complete without these guys. The Borg from Star Trek, yeah. And of course, there's some humorous renditions. I consider the Tin Man from Wizard of Oz to be a robot, if you think about it. It's an early one from the 1930s. Jaime the Robot from Get Smart. The Jetsons had kind of household robots that cleaned and cooked, and Rosie, I think, was it Rosie from the Jetsons? Yeah. Of course, now we got Roombas and other household robots that clean and do other things around the house. And of course, yeah, and yeah, this guy, Robin Williams, starred as some man. Good. Millennial, almost. Bicentennial, yeah, close. And that one actually was closer to the Asimov novel. In fact, when they first fire him up, the laws of robotics go up in hologram, and he's showing the family how he operates according to the 3 laws of robotics set forth by Isaac Asimov. And then, of course, Wall-E and Hitchhiker's Guide. Yeah. So speaking of Asimov, he wrote robot stories back in the 1930s and 40s, before computers even existed. And he wrote dozens and dozens of robot novels, and his stories revolved around the 3 laws of robotics, which we mentioned. So he put robotics novel stories on a very firm, almost like programming footing. And he was just a master at doing this. And the stories' plots revolved around the way these robots were programmed and the way they acted, the way they responded to their environments in different situations. And the laws of robotics, let me just quote them here because they're so profound. A robot may not injure a human through action or inaction or allow humans to come to any harm. A robot then, as a second rule, must obey orders unless it conflicts with the first law, with rule number 1. And a robot must protect its own existence as long as it doesn't conflict with the first or second law. So they had a certain priority about these laws. So this is almost like assertional programming, like prologue type programming or functional programming. And the 3 laws were introduced in 1942, before computers even existed, before electronic computers were invented or created by us. And he also invented the word robotics, interestingly enough. He coined that word, robotics. And there's the bicentennial man, Robin Williams, projecting in hologram the 3 laws of robotics that Asimov laid out in 1942, some 50 years before this movie came about, 55 years or so. So this is like logic programming or rule-based programming, but years before computers were invented, much less programming in Prolog existed, or any other language for that matter. Later there were other laws introduced, like law number 0, preceding the first law, saying a robot may not harm all of humanity, either by action or inaction, or allow humanity to come to harm, which precedes not injuring a single person. Because if you harm humanity, that's worse than harming one individual. So that law, for example, allowed the robot to kill a human if the human would do something horrific that would injure all of humanity, like start a new world war or detonate nuclear warheads or whatever. Then a robot could kill a human to prevent them from doing that. But with its original laws, a robot can still not do that. So they kind of over time modified the rules. And later they even put another modification. Instead of saying a robot may not harm humanity, it should not harm any sentience, any intelligent species, not just humans, because focusing on humans is too biased, right? So if you if you discriminate against other people based on their race, you're racist. If you discriminate based on their gender, you're sexist. If you discriminate against others based on their species, you're a speciesist. And we almost laugh, right? Because we don't hear that term very much. You're a speciesist. You're sexist or you're racist, but not you're speciesist. But over time, we'll hear that more and more as other species become more intelligent, or if we ever encounter other intelligent species, that will be, in more in common use. But if you think about it, we're all biased. We're all humanists, And when I say that now, I don't mean it in a good way. I mean it in the biased way, right? We're biased towards humans, and we kind of discount other species. In fact, not only we deprive them of rights and don't give them equal standing, we eat them for lunch every day. But I digress. But that's how these laws started. That's how they evolved. Let me show you some real-life robotics. So this picture here, these are robots, and these robots can crawl around on tracks in a field, and they have explosives on board, and they can be programmed to explode after they make a particular track. They can go like 100 yards forward, then make a left turn, go 20 yards to the left, and then detonate, or wait 60 minutes and then detonate again. So this picture, what era is this from? This is a real picture, historical picture. World War I. It's not World War II. You can look by the uniforms, these strange helmets and so on. This is World War I, over a century ago. They had robots already. They were primitive. They didn't have computers. They didn't have circuit boards or CPUs or programming, but they were mechanically programmed to. It was basically a roving landmine, a landmine that can move, and do things. Not many people know about this, but this actually happened. And later, these are today's robots that go around the battlefield. They're much more sophisticated. They have sensors. They have AI on board, chips, lots of memory, infrared vision, satellite communication, and of course a machine gun or two. And they go around killing people. This is not science fiction now. This is historical fact. These things exist right now. This one is even made by iRobot. So iRobot, the company that makes your Roomba vacuum cleaner for your house, makes lethal killer robots for the battlefield. How many knew that? Same company. Interesting. So it's basically a Roomba with a machine gun on top, with more tracks. And some of them can fire automatic weapons, and some of them have wheels, not tracks, and some of them can go really, really fast. This one can go like 60 or 70 miles an hour. It's a robot with tracks. And these are real products. These are real, machines right now that are out there, in various places around the world looking for perpetrators and programmed to kill. Interestingly, so these aren't that different from the first generation of Terminators in the Terminator movie. In fact, they look very similar. They have tracks and machine guns hanging off of them, and it's interesting. And they're becoming smarter and smarter. So talk about killer apps, right? These are killer apps. Literally, they'll kill you if you rub them the wrong way. So not just on the ground, but in the air. So you got your Reapers and Predators. These are fully AI, robots, unmanned. Many of them have missiles or automatic cannons. They can drop bombs. This is a Hellfire missile getting shot off of a Predator drone or a Reaper drone. Some of them are got jet engines, not just propellers. Some of them can go supersonic, some of them can go hypersonic, many times the speed of sound, not just at the speed of sound. And again, these are products. This is not science fiction anymore. This is real-life products by Northrop Grumman and Boeing and other military contractors. And then you have dirigibles, lighter than airships. Again, these are all robotic ships, all unmanned, weaponized platforms. Then you got hovercraft, various helicopters that are unmanned. Of course, now you got the drones, those quadrocopters. You can buy them at Toys R Us for $30 and, put a little, explosive on board or whatever it is you want to put there. So it's become really, really ubiquitous. But anything that can carry a camera can carry more nefarious payloads that are not so harmless. Here's one from about 15 years ago. Now it's much more advanced. It's a helicopter, unmanned. Autonomous mode, can loiter around, look for targets. It carries 2 automatic shotguns firing explosive bolts, not just shotgun shells. So interesting technologies. Again, robotic platforms. You got ones that are very small. Of course, now you can buy them at Toys R Us, but back 10 or 15 years ago, there were prototypes, and they were developed typically by ARPA or DARPA. So this one's the size of a pencil. This one the size of an insect. These are really tiny ones. And the smaller they are, the less they can loiter and hover. They have a battery life of only a few minutes, not hours. But all that's improving and improving pretty quickly. Typically they have a tiny little camera. They can do telemetry and surveillance and so on. And comes in really handy when you want to kind of inspect a building very quickly. Just release dozens of those into the air, and if one of them or 2 of them get swatted down or stomped upon, it no big deal. There's still dozens of others, and they can create a composite picture of the entire structure within seconds or at least minutes. Then ones on water. Again, these are all unmanned vehicles, robotic vehicles with AI on board. During the Chinese Olympics, a bunch of these robotic vehicles were patrolling the waterways, in China around the Olympic venues to provide security and defense and so on. Very effective. And of course, whenever you have a robotic platform, you immediately put a machine gun on board, because that's what we do as humans as a first instinct. And there's ones that are submersible. Again, fully robotic, autonomous or semi-autonomous submersible vehicles that can do discovery of wrecks and underwater mining and all sorts of things. This one has torpedoes on board, so it's not so peaceful necessarily in purpose. Others don't. And of course, you had the DARPA Urban Challenge when 2005, 2006, DARPA tried to create robotic cars and couldn't. For many years they tried, couldn't, even decades. So finally they put $1 million prize on anybody that can create a robotic car that can go about 100 miles through desert within a designated time frame, like 5 or 6 hours. None of them succeeded, so they upped the ante to $2 million the next year, and this time 5 or 6 teams have created vehicles that succeeded in going through desert. And they look very clunky, all these sensors. They basically took an existing vehicle, like a Jeep or station wagon or something, and SUV, and they put all these sensors and cameras and lidars and radars and infrared detectors and so on it, and it looked very clunky, but it did the job, right? And these are some of the winning entries, some of the ones that actually finished the course and won the $2 million prize. And one of them was even a motorcycle. So not only it had to robotically find the right path, and it also had to balance itself while it's doing all that, riding through desert. That was not an easy control theory kind of problem, how to balance yourself while you're looking for paths and so on. So I think about these as Turing machines with an O, and that was 2005, 2006, and here we are 12 years later, and now we got the Tesla Model S that can completely outdo these things, and this is a product. So not only it can drive itself on the freeway on its own, it can go 0 to 60 in 2.3 seconds, which is amazing, actually. It can outrace Lamborghinis, Ferraris, and Bugattis. And it's only a fraction, like a tenth of the price of these other supercars. It can self-drive on the freeway, not one day, but 2 years ago. It can already do that. And now it's even more sophisticated. And so you can compare the way self-driving cars looked like in 2005 to the way they look today. It's an incredible evolution in just less than a decade. Quite amazing. Here you don't even see the sensors that are embedded into the chassis and so on. And it's got multiple GPUs running, probably at teraflop kind of speeds to do AI, image recognition and so on. So of course I got my own, and next weekend I'm going to schedule a Tesla demo day. I'll bring it in maybe on a Sunday next weekend, and you can take it right. I think a lot of you probably have already seen it last semester. How many have already seen it? Anyway, we'll schedule it again. If you want to take a ride again, that's fine. Those who haven't, we'll make it available. I'll also invite my undergraduates too, so there'll probably be a big crowd. Anyway, robotics in space, that's been going on for a long, long time. since the 1970s. And the reason this has been kind of surpassing other robotics environments is because in space you almost have no choice. You got to send in robots because you're not going to put humans on Mars, very, very soon, or definitely not out to the planets and the moons of Jupiter and so on. That's very harsh, unforgiving environments, and humans that will go there will probably not come back, or at least the first few waves. So there you want robots to come in and do the job. Yeah. Students are allowed to drive my Tesla? No. I don't think my insurance company would be very enamored by that idea. Plus, you break it, you buy it. So, let's put it that way. If you can afford that, I guess you could drive it. Oh yeah? Oh, okay. We'll think about it. Anyway, so in space, we've been doing robotics for a long, long time, and for good reason. And of course, in our factories are becoming more and more automated. So most factories now, assembly lines, production lines, use robotics all over the place to the point that almost no humans need to be on the factory floor anymore, just to inspect and oversee what's going on, but not to do the actual heavy lifting and welding and painting and stamping of metal and so on. We already mentioned the Roomba. I got a couple of those, cleaning, vacuuming around my house, and there's lots and lots of versions of the Roomba type machines. Dyson makes one, and a dozen other companies make. Some of them are very large because they're for commercial spaces, so they're the size of this desk or something, and they can loiter for days on the same charge because they got this big battery, and they can clean an entire floor of a hotel just on a single charge. And of course, you got other kinds of robots. You got the Aibo from Sony. This was, again, 10 years ago. It's not even used anymore. You got robotic kind of pets that can fetch stuff for you around the house and so on. And I guess, and of course, there's the Asimov by Honda. And that's a progression of how it got smaller and more sophisticated. It can fetch things. It can make simple meals. Here it is conducting an orchestra, which is actually hard to do because you have to have a lot of dexterity and mobility to go through all the fine motions to conduct an orchestra. I think there's Yo-Yo Ma trying to kiss it at the end. I'm not sure, if he realizes it's a robot, but it's probably impressed that it can do such a good job conducting. It can play soccer. Not quite like humans yet, but there's a annual competition of soccer for robots called RoboCup, I guess, like World Cup soccer, and they're getting more and more sophisticated. But even biped motion for robots is not easy. It's actually hard for robots to stay on 2 feet and not just fall over and be able to compensate in real time for very varying conditions and slippage on the floor, and if somebody knocks into them, it's biped motion in itself, never mind going somewhere and doing a smart thing, is not easy at all, as researchers have found out. And then there's exoskeletons, robots that you can wear. Again, none of this is science fiction. This is all science fact. These are products, and some of them are prototypes, but many of them are actually products. So there's a robotic suit that you can wear, not quite Iron Man suit, but this will multiply your force by 5x, and battery will last a few hours, and it costs maybe $60,000. And if you can afford to buy it, you can rent it for about $600 a month. But this is a product. I guess we'll continue next time, but some robots can do surgery already. Robotic surgeons, like the Da Vinci system. So hospitals already been deploying this for almost a decade now, and they'll operate on you. And they can go in through incisions that are very, very small, almost like laparoscopic surgery, which is another form of robotics, but this is more autonomous, and they can do tiny little micro stitches inside you without having to open you up and create a larger chance of infection and complications. They can go in through a hole, and you can just be released from the hospital the same day because it's just a tiny little incision, and they can do pretty sophisticated microsurgery in a way that no humans can accomplish. So these robots actually are saving a lot of lives. Right, and becoming more and more reliable and sophisticated. Of course, there's always a couple of doctors that hang around making sure that everything goes correctly in case there's something glitches. You're not on your own just with a robot, but the robots are doing all the heavy lifting surgically and medically, during the operation, under the supervision of the doctors. All right, so we'll continue next time, but this weekend I'll set up a Tesla demo, say on Sunday. Last lecture will be next Tuesday. The exam will be available right thereafter, the last lecture, either on Tuesday or Wednesday, and that'll be the end. So everything you want to submit should happen before the last lecture on next Tuesday, a week from now. The final exam will be very similar to the midterm. You already know how it goes. There'll be 6-hour period over multiple days. You can do it at your leisure over that period, 6 contiguous hours. Any questions about anything, logistics or end of course stuff? So the last half of next lecture, like the last, say, 45 minutes or half an hour, I'll have like an Ask Me Anything session next time. I like to do that at the end of the semester. We can ask me anything you want about any topic whatsoever. Just be careful what you ask for, because I will answer. So we'll do that like at the end of the next lecture, which is the last lecture. All right, and maybe we'll go over a few general questions. If you have any questions about any material or problems on the problem sets or anything, bring them into the last session also. We'll try to cover that as well. Anything else for now? All righty. See you next time.